As we've navigated the different alarm views, I've intentionally skipped over the waveform buttons. Now, let's see what the software can give us in the way of waveform analysis. Before we do that, however, I need to cover some prerequisites for waveform capture. When I talk about a waveform, I mean an extremely fast sub-cycle capture of the voltage and current signals coming into a meter. The output looks similar to an oscilloscope trace. Obviously, this capture is far too fast to be done over communications, so our first requirement is a meter capable of capturing a waveform and storing it on board. In Schneider Electric terms, this means an ION 9000, PM 8000, or certain PM 5000 meters, as well as some older hardware. Secondly, having a capable meter may not be enough. The meter must be configured to capture waveforms on appropriate events. For ion meters specifically, this means setting a nominal voltage, but other meter lines will have similar requirements. Finally, we need a compatible communications protocol. IEC 61850 defines a standard method for gathering onboard alarms through FTP. Similarly, Schneider Electric ion meters can provide waveform data via ion protocol. Other protocols do not specify a standard location for waveforms, so we are limited to what has been explicitly programmed in the drivers. That is to say, the Power Modbus driver can gather waveform data from compatible Schneider Electric Modbus devices like the CM4000, PM800, and MicroLogic Type H. However, this is not available to just any Modbus device, only those that the developers have enabled it for. Now that we have the requirements out of the way, let's open up a waveform. I'll do this by clicking a waveform row in an incident view, but any of the waveform buttons in the status or history views would take us to the same place so long as a waveform was recorded. At the top of the page, I have the main waveform trace. To the left, I can change this to display peak-to-peak, RMS, or both. I can also disable different channels if I need to clean up the view. Back in the trace, the gray bar here indicates the waveform trigger time. Everything before this was recorded as pre-event cycles. I can see the exact trigger time in the left bar. I can drag the zoom bar to isolate just my event, and I can drag the analysis window to adjust what is being viewed in the objects below. These are only analyzing one cycle at a time, so I can drag this window around to see how my measurements change. Below, I have the analysis area displaying exactly what is contained in the window above. The phasor section gives me a phasor diagram as well as the RMS magnitudes and angles in the analysis window. I also have a map of the current and voltage harmonics measured in the window. Back to the pane on the left, the extended view zooms in on each pane for closer inspection. I also have many advanced options to play with. For example, auto scale y-axis is helpful in RMS mode because it eliminates the negative half of the window. Most of the other options are best left at the defaults. I have two remaining tools. Export waveform will save off the individual waveform samples as a CSV file, which is useful if you are not a power quality expert and instead want a consultant to analyze your waveforms. Compare waveforms will open the waveform in a new page. Now, if I go to open a new waveform and compare it, I can see the two side by side. Inspect will take me back to the main analysis window. These are the included tools used to analyze the gathered waveforms. If this is your area of expertise, I hope this enables you to track down the source of your disturbances. For the rest of us, let's continue working with the alarm views a bit. Until then, thank you.